Lesson 3.4, Proofs of Perpendicular Lines. Essential question, can you find the distance from a point to a line? Can you name the theorems about perpendicular lines? First, let's talk about distance from a point to a line. It is the length of the perpendicular segment. So this right here is what we call a distance from a point to a line. This is a path to the line, but it's not the distance because it's not perpendicular. All right, let's go ahead and find the distance. Notice that we want to go from point A to this line right here, and the shortest path will be this one right here. All right, so I'll start with the point -3, 3, and I want to go to the point 1, -1. That'll require me using the distance formula. -3 take away 1 quantity squared plus 3 take away -1 quantity squared. That will be 16 plus 16, which is root 32. If you put that in your calculator, that's about 5.7. If you want to put it in simpler form, root 32 is 16 times 2, or 4 root 2 would be the simplified form. All right, I'd like you to try that. Stop the screencast and then resume when you have the answer. Okay, here's the answer. It's around root 50, which if you want to simplify it will be 5 root 2, and the decimal is about 7.1. Okay, here are the three theorems concerning perpendicular. The first one goes like this. If two lines intersect to form a linear pair of congruent angles, so we know that the measure of angle 1 equals the measure of angle 2. We also know that they're a linear pair, so a linear pair means they're going to add up to 180. And since they're both the same, I'm going to substitute, and I'm going to write measure of angle 1 plus measure of angle 1 equals 180. That means two of these angle 1s equal 180. Divide both sides by 2, and I get angle 1 to be 90. Once I establish that angle 1 is 90, then I know that G is perpendicular to H. Now the next one talks about in a plane, if a transversal, so this line, is perpendicular to one of the two parallel lines, it is perpendicular to the other. And in a few minutes, I'm going to go through a formal proof of this. Let's take a look at the next one. In a plane, if two lines are perpendicular to the same line, so these two lines are perpendicular to the same one. Perpendicular means that they will both be 90 degrees. And if they're both 90 degrees, then we have corresponding angles congruent. So if corresponding angles are congruent, then we know the two lines are parallel. Okay, let's go to the theorem that I promised you that we were going to prove. We have one perpendicular to one of the parallel lines, and we want to prove perpendicular to the other parallel line. All right, first, since we have perpendicular lines, we know we have a right angle, so that's definition of perpendicular. Now, since we have these parallel lines, we know that angle 2 is congruent to angle 6 because if, I'm using this, if two lines are parallel, then corresponding angles are congruent. Now, I'm going from congruence to equality. That's definition of congruent angles. And now I'm going to take angle 2 out and replace it with 90, and that's called substitution. And once I've established that angle 6 is 90, I know I have some perpendicular lines, definition of perpendicular. All right, let's take a look at a picture where we really have to take a look at the theorems and make some decisions here. We want to look for perpendicular, and we're going to see that with the symbol. So it says AC is perpendicular to CD, so I know I have this perpendicular here. AC, CD, yes, that right angle means I have perpendicular. AC, CD, this one is perpendicular. AC, CD, I don't have the right angle, but I can see from this picture this is a square. And in a square, I know I have 4 right angles. So I'm going to say yes, I do know I have perpendicular. Even though I don't have this symbol there, I know by looking at it, that's what squares do. And then I have AC perpendicular to CD. So we know that all 5 of these have the perpendicular property here. Now let's talk about whether we see parallel. Okay, I can see that CD is a line where two lines are perpendicular to the same line. So if two lines are perpendicular to the same line, then the two lines are parallel. So I do have parallel here. Now, I'm not going to have parallel in B. Over here, I have CD again, and CD, these two lines are perpendicular to this CD, so I'm going to have parallel here. And here's CD again, and two lines are perpendicular to it, so I'm going to have parallel here. And here's CD, and I have AC and BD parallel to the same line, so I have parallel here. So it looks like everybody but B is both parallel, has a parallel property and the perpendicular property. Okay, I'd like you to try this problem on your own. Stop the screencast and see if you can figure out the value for x. Okay, here it is. I noticed that I had parallel lines, and I noticed that one line was perpendicular, the line A was perpendicular to one, so I knew it would have to be perpendicular to the other. So if a line is perpendicular to one or two parallel lines, it is perpendicular to the other. So that means I know all of these angles are 90 degrees. So I set this one equal to 90, and I got x equal to 8. And really, I'm done. But if you had chosen this other angle and set it equal to 90, you would have got 8 as well. Okay, let's take a look at this layout here and see if we can determine which, if any, must be parallel in the diagram. Well, I see right here, let me see if I can't get my red here. I see perpendicular here and perpendicular here. So that means these two lines right here, P is parallel to Q because they are perpendicular to the same line. I also see that these two lines are perpendicular to this one. So I'm going to say S is parallel to T. And I think that's about it. So those are the lines I have. I know nothing about U. I don't have any indication of U at all. Okay, let's take a look at this last one. Is B parallel to A? And B parallel to A. Now I do see a perpendicular and a perpendicular here, and I see them being perpendicular to A. So I can make a conclusion about D, but I really can't make, okay, I see another perpendicular right here, green and green. So I see that these two lines, A and B, are perpendicular to the same line, so yes, they will be parallel. And so we're going to say if two lines are perpendicular to the same line, then they are parallel. And that's the end of the screencast.